Welcome dear grade 10 students to our new chapter, Powers. You have an idea about powers since grade 7, 8, 9 and so on. You have an idea about powers, about multiplying powers, about exponents, positive exponents, negative exponents. But in this chapter you are going to see decimal exponents, you are going to see fraction, you are going to see nth roots, you are going to see fifth root, as you see here, you are going to see fraction exponents and so on. Let's start with a revision for what you know about powers. Definition of a powered number. So let A be any real number. The product A dot A or A times A is denoted by A squared. That's to say that A is multiplied by itself 2 times. We read it A squared or A power 2 or A exponent 2. While the product A dot A dot A is denoted by A cubed because A is multiplied by itself 3 times and it's read A cubed or A power 3 or A exponent 3. So in general, A dot A dot A n times multiplying A by itself n times is denoted by A to the power n or A exponent n. There are conventions that say A power 1 is equal to A for any A not equal to 0. A power 0 is equal to 1. So any number power 1 is kept as itself, and any number that's not 0, power 0 is equal to 1. That's a convention. So to sum up, we say that this number here, this real number here is called the base, and this power here is called the exponent. Properties you already know about powers, but like a little revision for them. Multiplying powers having the same base. So if you have two powered numbers of the same base, as you see here, A power n times A power m, notice that they have different exponents but same base, then all what you have to do is to add their exponents. Example, 7 squared times 7 power 6 is 7 power 8. We add 2 and 6. 5 power minus 3 and 5 power 7 when multiplied together will give 5 to the power 4 by adding minus 3 and 7. Dividing powers having the same base as well. A power m over A power n, surely A is not equal to 0. When dividing powers of the same bases, we have to subtract their exponents. Okay? So example, A power 3 over A power 7 is equal to A power 3 minus 7, which is A to the power minus 4. Power of a power. As you see here, you have A power m, all of it raised to power n. So it will be A power m times n. So we multiply the power of a power. Example, A power 11 power minus 2 is raised to power 22. So it is A minus power minus 22. More properties. For a power of a product. What do we mean by a power of a product? We have a product here. A times B form a product, and this is raised to power m. So all what we can do is to introduce the power among A and B. So as you see here, we can introduce the power in case we have a multiplication sign between the variables, but we cannot in case we have plus or minus between the variables. Remember this. So we can introduce the power along A and B as you see here. If we have A power n times B power m, all of it raised to power t, it is then A power nt times B power mt. So the power will be introduced and multiplied by each power inside. Example, 2 power 3 times 5 power minus 2 raised to power 4 is 2 power 12. 12 is from 3 times 4 times 5 power minus 8. Minus 8 comes from minus 2 times 4. Now power of a ratio means a quotient. For example, as you see here, A over B, surely B is different from 0. Power n is also equal to a power n over b power n, as if we introduced the power among a and b. Example, 2 to the power 5 over 3 squared power 4 is equal 2 to the power 20 over 3 to the power 8. By multiplying 4 and 5 we will get 20. By multiplying 2 and 4 we will get 8. More properties concerning negative exponents. You know that a power minus n is indeed 1 over a power n. So, the meaning of the negative exponent is that whenever you have a negative exponent, that means it's the reciprocal of the powered number. Examples here, 2 power minus 1, for example, is 1 over 2 power 1. So as if here you have 2 power 1. Okay? And 5 power minus 2 is 1 over 5 power 2. So that's the meaning of the negative exponent. Here is a rule or a remark that says minus a power n is going to be positive. The minus sign will be cancelled if n is even, while the minus sign is kept if n is odd. Examples, minus 5 power 8. Note that there is a negative sign inside, but since the power is even, then the minus sign will be cancelled because I'm multiplying minus 5 by itself even times. So in pairs, the minus signs are going to be cancelled and no minus sign will be kept alone. That's why the result is going to be positive, 5 to the power 8. While minus 311 power 11 will be minus 3 power 11 because I'm multiplying minus 3 by itself 11 times, which is an odd number. Then definitely there is a minus sign that's going to be kept alone without multiplied by another minus sign. And that's why the minus sign will be kept with this number. And you have to know that if you have minus 3 to the power 2 is not the same as minus 3 to the power 2, for example. The answer of this one is minus 9, so the minus is kept, and all what we have to calculate is just 3 squared, while the answer of this one is plus 9 because the minus is included inside the parentheses and the power can remove this minus sign. The even power can remove this minus sign. Here is a training example. We have minus 2 cubed times minus 2 power 5 times minus 2 to the power 4. It's minus 2 to the power 11 because I have the same base here and here and here, then I keep the same base. And all what I do is to add the exponents, which is minus 2 to the power 12. And since 12 is an even number, an even exponent, then the minus sign will be cancelled as you see here. While if I have minus 3 power 5 times minus 3 power 2 times minus 3 power 4, the base is minus 3, then I will get minus 3 all of it power 11. 5 plus 2, 7 plus 4, 11, and the minus is kept on the line here. Okay, because the power resulted, I will get minus 3 power 11. And since the power is odd, then the minus sign is kept and the result is minus 3 power 11. Or we can write it that way. We can know that since in our minds the power is odd, we can put the minus sign and we can add the exponents later. But writing that way is better.